Hi, everyone. This is the lesson for Chapter 5, Lesson 6. Today, we're going to talk about graphing linear inequalities. So, up until this point, we have been solving equations with linear inequalities or graphing it on a number line. So, before we talk about graphing an inequality, let's review graphing a regular linear equation. So, the standard form that we would use to graph a line would be y equals mx plus b. Let's kind of review what this would look like. So maybe we would have an equation where it was y equals 1/2 x plus 1, meaning I'm going to have a y-intercept at positive 1. And then it is the slope is up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. So if I were to graph a line, it might look something like this. So I've got my line here, and it's going to continue forever and ever, going through these points like that. Okay, so there's my line. Okay, so let's talk about if we had an inequality. So I'm going to keep this equation the same, but instead of writing it as an equal, maybe I'll write it something like y is less than 1/2 x plus 1. Okay, so the only thing that's changing is not having an equal sign. It is an inequality. It's a less than sign here. Well, what would this mean? This would mean that if I were to put up an ordered pair, an XY ordered pair, the whatever I put in for X would have to be greater than the output of Y. So let's say I use 0, 0, okay? So 0 times 1, if I were to create like a chart, I might have my X and then my Y. And so if I input 0, 1/2 times 0 plus 1 would equal 1, okay? So this is the actual equation or the inequality here. And so we have to see, okay, is this ordered pair fitting within this inequality? So is 0, when I replace it, is it in fact the output? Is it greater than what comes out to be in my equation? And so if I were to work this out, let's find some other room here. This would be 1 is greater than 0. Okay, so sorry, I'm inputting 0, 0. This would equal 1, right? Okay, so this does reign true, meaning if I have a point here, it does reign true for this inequality. And so when we are looking at graphing an inequality, what you're going to end up doing is you are going to graph your line as if it's an equation, a y equals mx plus b equation. And then we know that the solutions for x and y are infinite. There's so many possibilities of what x and y can be. It's not exact, it's not just one exact number that falls on your line. So what we see that is usually we're going to shade to one side of your inequality or one side of your line, meaning every ordered pair that's on this bottom half of this line can be a potential solution for x and y. So you could pick another point like 3, 1 and put it in place of your equation. So that means you would have 3 in place of y and then 1 or actually, no, we're going to switch these. It would be 1 in place of, this point would be 3, 1. So 1 would be in place of y is less than 1/2 times 3 plus 1. And we're going to check to see if this is true. So bring the 1 down, is less than 1.5 plus 1, which would be 2.5. And 2.5 is in fact greater than 1. So what we're realizing is any point that we pick on this bottom half of this line is a potential solution for this inequality. If I picked a point that was above this line, let's say 1, 4, and let me clear off some space here. So if I picked a solution that was an ordered pair of 1, 4, I would replace my y with 4 is less than 1/2 times 1 plus 1. And you'll see that if you work this out, 1/2 times 1 is 0.5, 0.5 plus 1 is 1.5. That is not greater than 4. And so this ordered pair is not a potential solution for this inequality. And so you have so many points, so many ordered pairs that you could replace this sub into this inequality and it would come out to be a true equation. This is just the big picture view. Let's go back up and kind of talk through what this is explaining. And so we've got some instructions here that explain to us how do we graph our inequalities when it's on a line. So a linear inequality in 2 variables has an infinite number of solutions. That's what we were just talking about. There is an infinite amount of ordered pairs you could plug into this inequality, and it would come out to be either a true solution or a solution that does not work. These solutions can be represented in the coordinate plane as a set of all points on one side of a boundary. And so what is this boundary? That's the boundary that you have graphed as a line. So this is what we call the boundary. One side of a boundary line. Let's be a little more specific, a boundary line. We show this by shading that side. The graph of a linear inequality is a region called a half plane. You're almost never going to be looking at an inequality and be shading the entire plane. Usually it's going to be one side of the boundary. So either the top or the bottom, and that's what we call the half plane. Is a region called a half plane that is bounded by a line. All points on one side of the boundary line are solutions. While all points on the other side are not solutions. A dotted line is used for inequalities with greater or less than. So dotted does not include the actual points on the line. A solid line is used for inequalities for greater than or equal to or less than or equal to. So when you see a solid line, that includes drawing any point on the line itself. So let's take a look at the first example where we're given an ordered pair and we have to sub the values in place of the inequality and see if this solution is valid or invalid, if this is true or not true. So if I have an ordered pair, 3 is my x, 6 is my y, which means when I plug this in, I'm going to rewrite this as 6 is less than 2/3 times 3 plus 4. So 2/3 times 3, this cancels. 2 plus 4 is left. And the result is 6 is less than 6. Okay, is this a true sentence? No, it's not. 6 is not less than 6. They're equal to each other. So in this case, this is not a true solution. It does not work. And so must must 3, 6 be a solution for y is greater than 2/3 x plus 4? If I were to plot that point on my graph, would that be a solution for this inequality? No, because anytime you have an untrue statement here, that means your x and y are not valid solutions for this inequality, because 6 equals 6. It's not greater than or less than or greater than. Okay. So let's talk about graphing now. Applying what we just talked about above here, let's look at our equation and start to graph. Now, actually, I already did this one as our initial problem, but let's just do it one more time to talk through it. When I see it's asking me to graph this inequality, first look at it as a regular y equals mx plus b equation, meaning you're still looking at this as m 1/2 x plus b, okay? So your intercept is at 1. The slope is going up 1/2. And then we're going to draw our line. Now we're going to draw this as a dotted line because it does not include, the inequality is not a greater than or less than. So if I could make this a dotted line, I would, but I'm having some trouble here with this. I don't know which dotted line. Not giving me an option. So this should be a dotted line. Let's see. It would look like this, right? Okay, so that's my dotted line. Then what you're going to do is you're going to pick a test point. You're going to pick a point either above or below this, and you're going to see if it is a solution for your inequality. So let's pick like 0, -2. So the point I'm going to pick is 0, -2. That means I'm going to put that in to my equation of y minus 1/2 x plus 1. So -2 would go in place of y, and it would be 1/2 times 0 plus 1. Meaning, when I work this out, it's 0 plus 1, so that's 1. Is 1 greater than -2, or is -2 less than 1? Yes. So this is a part of my solution. It's a potential solution. So I'm going to shade to the bottom half. The bottom half indicates any point on the bottom half is a solution for this inequality. Let's look at this one. If I were to identify my y-intercept, that would be -3. My slope would be -2/1. So I'm going to graph my line first, and notice that it is a greater than or equal to, meaning it includes whatever's on my line. So my line that I'm going to graph will be a straight, solid line. Intercept at -3, down 2/1. So I'm going to go the opposite direction, up 2 to the left 1. And I'm going to draw my line. That's going to look like this. Going through my points. Okay. Now I'm going to pick a solution either to the left or right or above or below, right? So I'm looking at this And maybe I'll pick 0, 0. That's always makes my math easier, right? So the solution, I'm going to pick a 0, 0. And then that means I'm going to replace y with 0 is greater than or equal to -2 times 0 minus 3. And so 0 is greater than or equal to -3. Is this true? It is true, okay? Which means this point, 0, 0, is a solution for this line. Therefore, I'm going to shade to the right. It's going to be shaded, including the point of 0, 0. So everything that's in the shaded area is a potential solution for this inequality. All right, let's keep looking. What if we don't have a y equals mx plus b type of equation? Now, remember, we've talked about when you have y equals a number or x equals a number, right? That means you either have a horizontal line or a vertical line. Well, same thing with an inequality. If this says x equals negative or x is less than -5, the big thing you really need to take note is there is a point on -5 on the x-axis. So the next thing you're going to ask yourself is my line going to be vertical or horizontal? Now, notice if it's horizontal, it's not just going through -5, right? That's going through every single point on my x-axis. So if I have x equals -5, that means it is intersecting on -5 on the x-axis. And the only way it can intersect the x-axis at -5 is if it's vertical. And I'm not able to draw an exact vertical line here because it's not letting me, but that's going to be your line. So cut through here vertically. That's my line. Now, because this is an inequality, it's saying x is less than -5. Well, what value for x would be less than -5? It would be anything to the left of -5, right? You could even see that on a number line. If you were to draw this on a number line, -5 is here. It would be anything to the left. Now be careful here because this line it should not be a solid line. It is a less than symbol. So when I look at my line, it should actually be a dotted line because that dotted line or solid line is going to tell you what type of inequality you're using. So trust what I have in the black. It should be shaded to the left of this dotted line intersecting at -5. Okay, so then if you have y is less than or equal to 2, that means my y-axis, it's cutting through +2 on my y-axis. And the only way it's cutting through +2 on my y-axis without cutting through any other point on my y-axis is if it's a horizontal line. And it is a solid line because it is a less than or equal to. So it includes the line itself. And then the only way to show that y is less than 2 is to shade below because that's where you have points that are below +2 on your y-axis. So I would be shading everything on this bottom half here. Okay, what about word problems? For a party, you can spend no more than $12 on nuts. So no more, meaning the maximum is $12. Peanuts cost $2 per pound. Cashews cost $4 per pound. What are 3 possible combinations of peanuts and cashews you can buy? So I know that if I'm kind of translating this, 12 is the maximum, meaning I could spend $12, but not more. And I could spend $2 per pound for peanuts, and I could spend $4 per pound for cashews. So P for peanuts, C for cashews. You could also write this as an XY ordered pair if you wanted to. It might be helpful if we're graphing to have an XY pair. So X being peanuts, Y being cashews. Now, from looking at this inequality, I'm not able to graph it because it is not in the form of y equals mx plus b. So I'm going to have to rearrange this. If I rearrange this, I want to isolate y, meaning I'm going to subtract 2x on both sides. And let me see if I can bring all this over here. So we have some more room. Then when I write this, I'm going to write this as negative 2x plus 12 is greater than or equal to 4y. I'm going to divide everything by 4 to get y by itself. And this will now be negative 2 over 4x, or we could say it's 1/2, negative 1/2 x plus 3. 12 divided by 4 is 3. So now this is in the form of y equals mx plus b. My equation would basically be that I have an intercept at 3. And if this were my x and y, I have a y-intercept at positive 3. And then it's going down 1 over 2, down 1 over 2, down 1 over 2. And this is my line. It's a solid line because it includes the inequality has an or equal to. Okay, so then I need to think through y is less than or equal to, meaning if I were to pick a point, I could pick any combination of points, but it should be shaded to the bottom, towards the bottom half. So you could pick any combination, like I could pick a point here, and this would be 2, 1, meaning x is 2 and y is 1. And if x represents your peanuts and y represents your cashews, then to spend no more than $12, you can either have 2 pounds of peanuts, 1 pound of cashews. You could have 1, 2, 3, 4, 5, 6 pounds of peanuts and 0 pounds of cashews. You could have 1 pound of each. You could have 2 pounds of cashews and 0 pounds of peanuts. All of these combinations will give you an amount that is less than $12. Okay, looking over here. You're writing an inequality from a graph. The boundary line is dashed and has a slope of 1/3 and an intercept of -2. The area above the line is shaded. What inequality should you write? So this time they're giving you the description of what your line will look like, and you have to come up with the inequality. So let's start with our y-intercept. It's at -2, and it has a slope of 1/3, meaning up 1 over 3, up 1 over 3. And it's a dotted line. Okay. So here's my dotted line. What kind of inequality would I write? Well, first of all, I think you can write the equation itself without thinking through the inequality. It would be 1/3 x minus 2. Y would be over here. Now we have to think through, is this going to be greater than or less than? It's shaded above the line, meaning whatever point you pick for x and y will be above. Above normally means greater than. So it's greater than 1/3 x minus 2. Let's fill in the blank here. When a linear inequality is solved for y, the direction of the inequality symbol determine which side of the boundary line to shade. And I don't know if you've noticed that already. If the symbol is less than or less than equal to, shade left or below, because we know that these are below the boundary line. If the symbol is greater than or equal to, shade to the right or above it. And we can glance back at all the inequalities that we looked at earlier and see this to be true. We use blue. This is a less than symbol. I'm shading below. This is a greater than. I'm shading either above or to the right. This is a less than symbol. I'm shading to the left. This is a less than or equal to symbol. I'm shading below. This is a, let's say, we need to flip this around. Y would be over here. Y is less than or equal to negative 1/2 x plus 3. It's less than, I'm shading below. In this case, y is greater than, I'm shading above. So the inequality symbol itself should tell you what direction to shade. Notice that y is always on the left. If it is on the right of the equation, like right here, you've got to flip it back around in order to shade the correct direction. Okay, that's all I have for today. We'll see you next time.